Hello students and viewers, this is Yeteta from Morogoro, Tanzania. My name is teacher Ramadhan Kadeghesho, a teacher of chemistry. Now I will proceed from where I ended in the last lesson. As you remember, the topic which I began to teach in the previous lesson is acids, bases and salts, and the subtopic is acids and bases. So today I will proceed from where I ended. Where I ended in the last lesson is laboratory bases. Laboratory bases. So today I will proceed. We shall start by discussing classification of bases. Classification of bases. The bases are classified into two parts. The first one is a basic oxide and the second one is basic hydroxide. So we have a basic oxide and also we have a basic hydroxide. Now I shall explain one after another, starting with basic oxide. So students, can you define basic oxide? Very good. By definition, we can say basic oxide is the base of oxide compound. Basic oxide is the base of oxide compound. For example, calcium oxide. Not only calcium oxide, but also sodium oxide is a basic oxide. Also, the basic oxide are classified into two parts. Which are those, students? The first one is called soluble oxide, and the second one is called insoluble oxide. The soluble oxide is alkalis, and the insoluble oxide are called basic. The point to note here, all soluble bases are called alkalis. All soluble bases are called alkalis. That's why the soluble oxide are called alkalis and the insoluble oxide are called basic oxide. Another part of base is basic hydroxide. Students, what is basic hydroxide? Good try. By definition, you can say basic hydroxide is the base of hydroxide compound. Basic hydroxide is the base of hydroxide compound. For example, sodium hydroxide, magnesium hydroxide, calcium hydroxide. These are examples of basic hydroxide. Also, the basic hydroxide are classified into two parts. The first one is soluble hydroxide, which is called alkalis, and the second one is insoluble hydroxide, which are called basic hydroxide. So we have alkalis, which are soluble hydroxide, and we have basic hydroxide, which are simply called insoluble hydroxide. Now, after that, I'm going to explain to you the physical properties of base. The physical properties of base. The first one, the base have a bitter taste. So the taste of base is a bitter. Not only that, but also base turn red litmus paper blue. I mean, the red litmus paper is turned to blue when it's dissolved in, or when it's mixed with what? When it's mixed with base. Another, base have a soap slippery feel. Base have a soap slippery feel. Another, most are insoluble in water. Most of bases are insoluble in water. Not all, but most of them are insoluble, do not dissolve in water. And from this point here, I can say that all soluble bases are called alkalis, but all insoluble bases are called base. So we have alkali and we have base. Base are insoluble bases and alkali are soluble bases. That's a very important point to note. Another thing which I'm going to explain is the chemical properties of base. Chemical properties of base. The first one, base react with acid to form salt and water. Base react with acid to form salt and water. I mean that if you take acid and then you react with a base, the product which is produced there is salt and water. For example, the reaction between hydrochloric acid and sodium hydroxide. Hydrochloric acid and sodium hydroxide. The product which is produced there is sodium chloride as a salt and water. Another example is the reaction between calcium oxide and sulfuric acid. Calcium oxide and sulfuric acid. The product which is produced there is calcium sulfate as a salt and water. So this is the reaction between acid and base. The second property, alkalis precipitate insoluble metal hydroxide from their salt solution. I mean that if the base react with a soluble salt, the precipitate is formed. Insoluble salt, another insoluble salt is formed. For example, the reaction between potassium hydroxide and iron chloride. The reaction between potassium hydroxide and iron chloride. Potassium hydroxide and iron chloride. The product which is formed there is iron hydroxide, which is insoluble, and another product is potassium chloride. So potassium hydroxide is insoluble. So this is the insoluble base which is formed after the reaction between potassium hydroxide and iron chloride. Another chemical properties of base, alkalis react with ammonia salt to produce ammonia gas, water, and salt. Alkali react with ammonium salt. The product which are produced there are ammonia gas, water, and salt. For example, the reaction between ammonium chloride and calcium hydroxide. Ammonium chloride and calcium hydroxide. The product which is produced there is calcium chloride as a salt. Another product is ammonia gas, and another product is water. So this is the reaction between ammonium chloride and calcium hydroxide. So these are some chemical properties of base. Now on, I'm going to explain to you the strength of base. The strength of base. Here in the strength of base, we're going to look at the degree of dissociation of atoms of base when dissolved in water. And the base here can be classified into two. The first one, we have a strong base, and the second one, we have a weak base. So strong base and weak base. Now, starting with a strong base. Students, can you define a strong base? When you are talking about a strong base, this is a base whereby all atoms present in a base dissociate completely when dissolved in water. And what is formed there is hydroxyl ion and a positive ion of base. Hydroxyl ion and the positive ion of what? Of that base. So strong base is the base whereby all atoms present in base dissociate completely when dissolved in water, and what is formed there is hydroxyl ion and the positive ion of that base. Examples of strong base. we have a sodium hydroxide. When dissolved in water, it will dissociate into sodium ion and hydroxyl ion. Another example is calcium hydroxide. Also, the calcium hydroxide, when dissolved in water, it will dissociate into calcium ion and hydroxyl ion. For that case, these are examples of a strong base. The second we say weak base. The second class is weak base. Students, what is a weak base? Very good. By definition, we can say weak base, this is the base whereby all atoms dissociate partially when dissolved in water. And what is formed there is what? Is hydroxyl ion and the positive ion of that base. So this dissociate partially in case it is dissolved in water. Now, example of weak base is ammonium hydroxide. What is produced there is ammonium ion and hydroxyl ion. But the dissociation takes place partially. So these are classes of base due to the degree of dissociation. Now on, I'm going to explain another thing which is called concentration of base. Concentration of base. As I said in the previous lesson, that concentration is the amount of a substance or is the amount of a compound present in water. Amount of a substance which are present in water. That's all about the concentration. So, concentration of base, this is the amount of base which is present in water. Is the amount of base which is present in water. And here we have a concentrated base. Also, we have a diluted base. The concentrated base, I mean it contains little amount or not at all. Little amount of water. This one contains a little amount of water. This is a concentrated base. But the diluted base contains more amount of water. Diluted base contains more amount of water. For that case, both weak and strong bases are either concentrated or diluted. Both weak and concentrated, weak and strong bases are either concentrated or diluted bases. After all that, I'm going to explain to you the uses of alkalis or the uses of base. The first one, it is used in various neutralization process. That's the first one. The base are used in various neutralization. It can be used to neutralize acid in stomach. It can be used to neutralize acid which is present in soil and the others and others. So it is used in a various neutralization process. The second one, it is used in the manufacture of cleaning agent. It is used in the manufacture of cleaning agent. The third one, it is used in various industrial processes like manufacture of paper. So this base one is used to manufacture paper. Not only that, but also in the manufacture of soap or soap making. So this one base also can be used in the manufacture of what? Of soap. So it is used in the industrial process like manufacture of paper, manufacture of soap, and the others and the others. So these are some uses of base. These are some uses of bases. Now, I'm going to explain another thing which is called neutralization. Students, can you define neutralization? Very good. By definition, you can say neutralization, this is the reaction between acid and base to form salt and water. So neutralization, this is the reaction between acid and base, and the product which is produced there is salt and water. Point to note, the volume of acid neutralized alkali are called titri. So we have a titri volume. So that volume of acid which neutralizes base are called titri. And the method of neutralization is known as volumetric titration. The method of neutralization are called volumetric titration, since it involves the quantity of volume of titri. Because it involves the quantity of volume of titri, that's why it's called volumetric titration. Now, application of neutralization. The neutralization is applied in various matter. The neutralization process is applied in various matter. The first one, it is used for treating insect stings and bites. It is used for treating insect stings and bites. The antibiotics can either contain the antibiotics, insect sting or antibiotics can contain either acid or base. So the neutralization process can be used to neutralize either acid or base present in that insect stings or insect bites. So antibiotics and nitro sting contain methanoic acid. So by using either baking soda or other base, it can neutralize that methanoic acid. Wasp stings, this contain alkaline. By using vinegar or acetic acid, you can neutralize that alkaline which is caused by wasp stings. So the first one, it is used for treating insect stings and bites. The second one, it is relief in digestion. It relieves indigestion. Stomach pain caused by presence of excess acid. The acid which is present in the stomach is hydrochloric acid. So if it is present in excess, it can cause the pain in stomach. So it can be relieved by using either magnesium bicarbonate. You can use magnesium bicarbonate to relieve that pain. Or you can use sodium bicarbonate. You can use sodium bicarbonate to relieve the pain which is caused by the excess acid which is present in the stomach. Another is soil treatment. When the soil is too acidic, lime material can be used. And the lime material including calcium oxide or calcium hydroxide or calcium carbonate. When added, it neutralizes that acid which is present in soil. It is used for treating factory wasters. The waste from the factories can be neutralized by acid. Some of wastes are acid. Let's assume for those industries which are used to produce acid. So their wastes actually contain acid. To neutralize that acid, you can use a basic. You can use a base or you can use the lime material. Another, it is used, a neutralization process is used to manufacture fertilizer. Neutralization process can also be used to manufacture fertilizer. For example, ammonium fertilizer. Ammonium fertilizer produced from neutralization between ammonia gas and the mineral acid. So if you take a mineral acid and then you react with ammonia gas, what is produced there is what? Is ammonium fertilizer. For example, if you take nitric acid, then you react with ammonia. The product which is formed there is called ammonium nitrate. So that ammonium nitrate is used as a fertilizer for the growth of crops. Not only that, but also sulfuric acid also react with ammonia to produce ammonium sulfate. Also, ammonium sulfate can be used for what? For the growth of crops in the farm. So for that case, we can say that neutralization process can be used for manufacture of fertilizer. Another neutralizing accidental spill chemical are used to neutralize accidental spills chemical. It can happen when the chemical is transported from one place to another. It can spill. Not only that, when it is used in the laboratory, it can spill. So we can use a base to neutralize that acid. If it is spilled in the laboratory, we can use a base to neutralize that acid which is spilled there. Or in case you transport from one place to another, then if it happen leakage and the chemical spill, we can use base to neutralize that acid because the acid is corrosive. If it's left, it can cause the death of animals and other living things. So the neutralization process also is used to neutralize the accidental spills chemical, either acid or base which are spilled. Another neutralization process used to reduce acid rain occurrence. Also, it is used to reduce acid rain occurrence. Here in this point, you can say that the acidic rain can either be caused by the gases which are produced from the industries. So, by using a neutralization process, it is very possible to neutralize that acid, and the possibility of acidic rain occurrence will be reduced. So, also neutralization process is used to reduce the acid rain occurrence. That's the last point of acids and bases subtopic. Now, let's go to another subtopic, which is called the indicator. Students, can you define indicator? Good. By definition, you can say, indicator is a chemical compound that shows the definite color change in acid or base. This is a chemical compound which shows a definite color change in acid or base. In case you take the indicator and then you put in acid, the color will change. Also, if you put in base, the color will be changed. So this one shows the definite color change when it is in acid or when it is in base. So for that case, the indicator is used to test whether the chemical is acid or base or neutral. You can use to test if it is acid or if it is base or if it is neutral. You can know the chemical by using indicator concern. So the common indicators. The following are common indicators. The first one, we have a litmus paper, abbreviated as LOT. So LOT is a litmus paper. Another is called the phenoliphthalein indicator. This phenoliphthalein indicator is abbreviated as POP. Another indicator, another common indicator which are used either in the laboratory or in any other place is called the methyl orange indicator. And the methyl orange indicator is abbreviated as MO. And another one is the bromothymol blue. And this one is abbreviated as BB. So these are common indicators which are used in various processes of life. Litmus paper, phenoliphthalein indicator, methyl orange indicator, bromothymol indicator. Now, I'm going to explain the color change of common indicator. Now here we have from the table here, we have the common indicator, we have the acid, when the indicator is in acid, and also when the indicator is in base. The first one is litmus paper, LOT. When the litmus paper is in acid, the color will change to red. But if it is placed in base, the color will change to blue. So the litmus paper in acid is red and in base is blue. Another indicator is the phenoliphthalein Pop indicator. This one, when it is in acid, the color is colorless. But when it is in basic, the color is red. So it is colorless in acid and red in base. Another indicator is methyl orange, MO indicator. I mean, when it is in acid, the color is red. But when it is in basic, the color is yellow. So red in acid and yellow in base. Another indicator is the bromothymol. Bromothymol. This one is yellow in acid and blue in base. So when it is in acid, is yellow, and when it is in base, is blue. After that, I'm going to finish by explaining to you one thing which is called the pH scale. Students, can you define pH scale? Very good. By definition, we can say pH scale is the scale that indicates acidity and basicity of a solution. So this is the scale which shows the degree of acidity and basicity of a solution. From 0 to 6.9, the solution is acid. 7, the solution is neutral. From 7.1 to 14, the solution is basic. So we have acidic solution, we have neutral, and we have a basic solution. From 0 to 4, this is a strong acid. But 4 to 6.9, this is a weak acid. From 7.1 to 11, this is a weak base. And from 11 to 14, this is a strong base. Now, let's look at the relationship between pH scale and acidity. The relationship between pH scale and acidity. So the pH scale is inversely proportional to the acid. I mean that the increase of pH scale, acid decrease. If the pH scale increase, the acid decrease. And mathematically, you can say pH scale is equal to 1 divided by acidity. But the relationship between pH scale and basicity is that pH scale is directly proportional to the basicity. As the pH scale increases, the basicity increases. So pH scale is equal to basicity. This point marks the end of my presentation. You were with me, teacher Ramadhan Kadeghesho. Thank you for listening. Thank you for watching this video. Goodbye.